Welcome to the factory laboratory. This is a new laboratory that we started in 2018. It is a laboratory in which we develop real manufacturing lines models, and we develop them with models that are available in the market, such as Lego and Arduino and so on. So I'm going to show you a bit the lab. Here we can see one of the typical systems that we can develop. It is a system that is, as you can see, it is composed mostly by Lego Mindstorms components. Here you can see parts are moving around. What do I mean by parts? Well, this wooden disc, they can represent parts and products that are moving around real manufacturing lines. For example, you can imagine a water bottle or electrical vehicle engine as well. We just represent the flow of parts around the system. Conveyors are moved by electrical motors, and they bring parts from one station to another. Here you see, when a part arrives to a station, the station accepts the parts and let the part inside the station. When a part is into a station, we can simulate a real manufacturing process, such as, for example, milling or turning, or a quality check, for example. And in this way, we can simulate what could happen in a real manufacturing line. What we can gain from this experience, we can recreate dynamics and calculate the performance of the system. For example, we can change the maintenance policy in the system and see what happens. We can change the number of parts. We can calculate how much the system is spending energy and maybe develop energy-saving algorithms and so on. So the development of such models is very important, and it is beneficial to both research and also teaching purposes. And in this lab, we have also a student association. As you can see, we have our guys that are working over new models that we are developing for the next year. In these new models, we are using different layouts and different ways to bring parts around. So, what happens when we develop new models? We can also create models that, with a larger complexity and a larger size, such as the models that you can see in this part. Here you see a model that is developed and composed by 6 stations. The stations are done in the same way that I told you before. So they are stations that allow parts to come in, go around in the conveyors, and be accepted and enter the station. Why we develop more complex systems? Well, in this developing new systems and more complex systems allows us to use them for teaching purposes, but also for industrial projects. For example, we exposed this system in a startup incubator in Bologna last year. And then we have also interest from other manufacturing companies that are interested in recreating the dynamics that happen in their system to study how to better react and how to develop algorithms for optimize the production. And another thing we can do is that we can develop dashboards such as this one that are very common in the Industry 4.0 world. And thanks to dashboards, we are able to get data from the system in a real time, and we can link the real system with simulation models and effectively creating digital twins. So thanks to these more complex systems, we can also provide companies and the research community with new ideas and new algorithms for production optimization. And in the next year, so we will develop other systems, and we will also develop a competition that will be, the competition will be sending our models on a global scale, and we will compete with other universities in making new models, and for example, models that optimize the energy efficiency, and models that optimize the production volumes, or they might reduce emissions, for example. Here I just started the system, and you can see that the working principle is similar to the other system. So we have parts that are accepted by stations, loaded from the stations, and then unloaded after the working has been done. Here you see a part has been just finished one operation, and in this way, at the same time that the parts are being worked, we have that our dashboard is collecting data from the system, and it's telling us how many parts each station have done, so we can calculate the production, and at the same time we can see the status of the machines. So for example, we see that one machine has failed, so we have to do something here, and then we can also see the buffer levels at the two machines, so we can see how many parts are in those machines, if there are many parts or not so many parts. And as I was saying, in this way we can collect data from the system and couple the real system with the digital models. Here you see another system that we developed last year. It is a system in which we have three types of parts, so not only red parts but also blue parts and white parts, and in this way we can simulate the multi-product lines, so lines in which more than one type of product are being processed, and we have also parallel machines, so we have three different stations, and the parts are loaded into the station according to certain scheduling principles. So in this way we can, for example, optimize the scheduling and the scheduling algorithms that are done into the production. So thank you very much for attending this visit, and I hope to see you around soon in the department.